Here are the steps to create a scatter plot, trend line, all done within the Halton Cloud using Google Spreadsheets. So we're going to create a spreadsheet. And within the spreadsheet, you have different cells. So you can set yourself up in any cells you want. And let's put in our XY data. It's good to put units, and if you put them right in the titles, you don't have to carry them through each column. So I'm just going to use some random data here to illustrate how to create a scatter plot and then an associated trend line with that. Okay, so just going to take the time to improve the appearance of the data, just to show you how this works. There's some menus up here that let you bold, of course add some highlighting. So I'm just going to bold those. My preference, and typically you'll see that table data is centered. So I'm going to highlight the entire thing and put a border around it. Oops, one more time here. Missed the click. Right there. Great. So I've got time as my X variable and position as my Y variable. So we're going to select that entire table, which tells Google Spreadsheets you're going to use that data. And then we're going to go to Insert. Okay, and it's a chart. Okay, so within here, there's lots of options. If you come over to Charts, it's an XY scatter plot. Okay, and if you select this type, you get an idea of what it's going to look like in the preview. Okay, you can also customize this. So let's take a peek in here. And so we can give it a title. Okay, so a title for this would be, of course, appropriate with regards to what experiment you're doing. I'll let you decide on that. If you want a legend, we don't really need a legend. So I'm going to go with none. Here you can see this is our X value data. It lasts approximately the 5-second duration. And our position data, they decided on a scale that goes up to 24 meters. And you're able to change these things to suit. So if I'm dealing with the horizontal axis, that would be my time axis. I can give it a min and a max. So if I know I lasted 5 seconds, might as well change that. Okay. So you see it adjusted the time labels here all the way to 5. You can also put what's known as grid lines. So I'll add some here. Why don't I change this to 2? And you can see it's separated these. So there's more separation along the X. They added this line here, that line there. You can play with this. If I had 4, it's pretty good separation. This is 0.0 seconds, 0.2 seconds, 0.4 seconds, 0.6, 0.8, and then 1 second, etc. I like that, so let's go with that. Okay. The other thing I want to do is give this a title. This is time. And we know we're measuring in seconds, so it appears down here. And I think that's pretty good for the horizontal axis. Now we've also got to deal with our vertical axis. By the way, our horizontal axis is known as the independent variable, x. And the vertical axis, which I'll change to now, the left vertical axis, is our y-axis, or dependent variable. Okay, so since this is position, and our position is measured in meters, I'll add that. It starts at position 0 meters, and I didn't get any higher than about 25, so I'll include that maximum. And I'd like to have some grid lines, and the reason we're going to have these grid lines will become apparent a little later here. So it's going up every 5, which is what this major grid line does, and then you can split them with minor grid lines, and that looks really good. Okay, so we've got a title. It's kind of generic. We've got time axis, vertical axis. We've got these scattered points. The only thing we need to do now is we want to try and come up with an equation, or what we call a model. We want to model how this data behaves, how this situation can be predicted, how it behaves as far as how does time change the position of the object here in question. And what you can do is you can add what's called a trend line. Okay, and you kind of got to look at your data and you got to say to yourself, well, does this look linear? Does there appear to be no data? As you move into further into your math courses, you might say, does this data look periodic, maybe sinusoidal? In our case, it looks quadratic. And a quadratic is a type of polynomial. And if you know your polynomials, it turns out that a quadratic has a degree. It's very specific, and it's degree 2. And if you notice right now, I picked some data that very closely allows these data points to get onto the trend line. Our trend line, that's a polynomial degree 2 or a quadratic. Okay. Another thing you can show is called the R squared. And R squared, basically, whenever you fit a trend line, this curve here, which is called the trend line, because they can be curves, they can be lines. When you fit them, the R squared is like a measure of how good the fit is. And for now, just take my word, we want R squared ideally to be as close to 1 as possible. Sometimes R squared is only equal to 0.98. Maybe it's equal to 0.02, which would be terrible. But R squared is like a measure of how well the line fits. Okay, so we're going to leave that. You're able to play, of course, with the line's thickness. If you want it to be thicker, that's fine. If you want to have it so it's a little more visible, you can play with its opacity. And I think I'm happy. All right, so make sure you give this a title, check it over in the preview. When you're happy, you can click Insert, and it goes into your spreadsheet. Great, so now that you have this in your spreadsheet, you can see that you have a certain time, certain position, it's visible in a graph. Just show you if I end up playing with this data, let's change this value to 10. It adjusts the trend line. Okay, and this trend line here, you know, it's trying to fit the data, and clearly it's not as good of a fit as the one we had before. That's because when I picked this data earlier, I kind of fixed it so it would fit, and then when I made this change, now it doesn't fit anymore. So change it back. Not all your data will fit perfectly. It depends how well your experiment was ran. There's a lot of contributing variables that can affect that. Nonetheless, with your data, you're going to want to generate these XY scatter plots and these trend lines, and I hope this method helps you with that.